Good morning, everyone. My name is Brent Lunsford, and I'm glad you could join us for this second webinar in a webinar series hosted by the IEEE Standards Association and the IEEE Sensors Council. Today's webinar will discuss the path for sensors interoperability, and the webinar features a sensor manufacturer and a gateway vendor. So again, glad you could join us. We need to thank our technical sponsors. Again, IEEE Sensors Council is working closely with the IEEE Standards Association on this webinar and advancing sensor standards. The IEEE Industrial Electronics Society, the IEEE Instrumentation and Measurement, and Foundational Technologies. Let me say a few words about the IEEE Sensors Council. The Sensors Council was formed in 1999 to advance and coordinate scientific and educational work in the field of sensors in theory, design, fabrication, manufacturing, and application and devices for sensing and transducing physical, chemical, and biological phenomena. The Sensors Council is not focused on a specific technology like photonics, but the overall field in general. 26 of our 39 IEEE member societies are members of the IEEE Sensors Council. We have chapters in all geographic regions across the world. Our main activities include publications. We sponsor and co-sponsor 8 peer-reviewed journals. We have industry events. This includes our flagship Sensors Conference. This year's flagship Sensors Conference will be held in October in Sydney, Australia. It's a virtual event. Next year's IEEE Sensors Conference will be held in Dallas, Texas. I encourage you all to join. This is our flagship event. We also have the IEEE Inertial Conference. That is the International Symposium on Inertial Sensors and Systems. And we have the IEEE Conference on Flexible Printed Sensors and Systems. We do a lot of education and outreach, and we have a host of awards that go to sensors innovators and people that have made major contribution to the field of sensors. The IEEE Sensors Council is ideally suited to discuss and tackle the IoT-enabled sensors and advancing the standards. 3 housekeeping items here. When you enter the webinar, all the lines are automatically muted. This is a one-way broadcast. If you have any technical issues, use the chat feature and message the host. To ask any questions, and we encourage questions throughout the webinar, use the Q&A feature. With that, I'd like to hand this off to our first presenter, who will introduce himself.
Okay, Brent, thank you very much. My name is Artur Zanek. I am, first of all, Brent, thank you very much for this invitation for today's webinar. And together with, my 2 of my friends, it means Van and, Cheryl, we present such kind of, our path to this kind of, sensor interoperability. A little bit about myself. My name is Artur Zanek. I am the General Product Manager responsible for IIoT, Industrial Internet of Things, and all the, sensor technology for, for ABB Mechanical Power Transmission Division. I'm leading right now the team of the, the 30 people, so just on this kind of, engineering side and product management side. We are treating this kind of IIoT very, very seriously. During my last, 20 years of the professional careers, I was responsible for the research and development, from the leading the plant, building the plant, and during the last 5 years, being located with the, Mechanical Power Transmission Division in Greenville, South Carolina, definitely.
Good morning. This is Cheryl Beeler. It looks like we have lost Arthur during our presentation. Not entirely sure what he was going to say, so let me move forward here. Our agenda today is to talk about our smart sensors for the power transmission side. Certification is a key element of the interoperability. We want to define what is interoperability from a sensor and gateway perspective, and then what are the common interoperability challenges facing the IoT enterprises. What solutions have we had to each of these challenges, and what are the common challenges facing the end users? And then we'll close up with a summary at that time. So as you can see from this slide here, the smart sensors for power transmissions, we have sensors that communicate to either a mobile application unit or some kind of a gateway router going into a cloud-based platform. This platform then can be accessed from external customers and go into smart sensor portals, or again, a mobile app that can go into a powertrain portal and be accessed by the users as well as the operators. Arthur, are you back?
Yes, I am back. Let's say thank you very much, Sharon, that you took over it for a couple of seconds. Yes, thank you very much. Some technical, let's say, technical challenges with the internet. It means, Sharon, thank you very much for the introduction. Thank you very much to walking us through the agenda. And as you can see right now on this slide, let's say we have a couple of different block of activities on the left-hand side of the screen. You can see this kind of hardware part of the, let's say, of IIoT, any IIoT platform. This is why when we are talking about the sensors itself, this is this kind of first element, what you're supposed to consider in your system. You are the, let's say, the product owner, you are, let's say, the decision makers. You have to really work with the customers to, let's say, to decide what kind of sensor technology, what kind of sensing technologies you wanted to use. Also, what kind of information you wanted to provide to, let's say, to the end customers, to the users. Also, on the left-hand side, you can see, let's say, the two communication protocols, two communication models. From one side, let's say, you can see the mobile applications, mobile phone. It means it's very difficult right now to imagine that we are not able to use the mobile phone to collect the data from the sensor itself. This is why we have to take these sensors into the consideration for any IIoT platforms. But of course, sensors also have such kind of, let's say, downsides. Downside of the sensor is that, let's say, that we are collecting a little bit historical data. Our sensors who are analyzing, let's say, the temperature and vibration, collecting the temperature and the vibration data, is able to store the data from, let's say, from the 60 to up to 246 days, depending on the measurement interval. This is why you have to take into the consideration also this kind of, this kind of communication protocols what you wanted to use. Of course, let's say, as I said, let's say, mobile phone is able to, let's say, to collect this kind of historical data. You will never lose those data. But of course, we have, let's say, the better solution, especially for such kind of approaching to the, let's say, predictive maintenance. Gateway is such kind of our solution that customers really are able to see the live data. This is why, as you can see on the bottom of the left-hand side of these diagrams, we have a gateway. Gateway is able to, let's say, to collect the data from the sensors automatically, almost immediately after sensor is collecting the data, and then send this data, let's say, securely and surely to, let's say, to the cloud-based platform. Right now, we are on the middle of the, let's say, of the presentation, on the middle of this kind of block, and we have two very important elements here. First is the cloud-based platform. We used to think that this is just, let's say, storage area, but this is much more functions we have there. We have some, let's say, some cybersecurity. We have some function inside. We have some calculations there. We have some machine learning models there. This is why all those areas, they are on the center of this kind of, let's say, this kind of solutions. On the, let's say, on the bottom of the center, we have also something what we as the owners, we're supposed to also take into the consideration. It means external customer systems. Depend of the, let's say, your customer base, depend of the market research, depend of the, let's say, market what you are going to serve. Let's say you have to take into the consideration something what we call voice of the customers. When our customers said, let's say, that we wanted to use this data for this particular purpose, this is why we have to give to, let's say, to our customers capability to, let's say, to transfer the data from the sensors through the gateway to this kind of external system. what kind of protocols we are wanted to use, and let's say for sure, let's say Van will talk about this, let's say a little bit later on during our presentation. Means right now, as you can see, let's say we are on the middle of these diagrams. On the right-hand side of these diagrams, we are able to see this kind of user interface. User interface on the top of the, let's say, right-hand side, we have a smart sensor portal. This is such kind of PC-based web platform. Then the customers, they are able to, let's say, to manage users, manage assets, manage the, let's say, KPIs, play with the KPIs, download the data, all these kind of areas, they have to be there. On the bottom of the right-hand side, one more time, this is mobile applications. On the, let's say, on the left-hand side, we are collecting the data. It means data need to be collected, sent to the cloud. On the right-hand side, for such kind of on-site access, users need to also have the access to this data almost immediately. When you are walking through, let's say, through your plant, or we are walking on the customer's locations, you wanted to have such kind of, on-site, on-spot, let's say, information on what's going on with the system. This is why you can see that this is the first element that this kind of interoperability play very important role, because you have to play on the both sides. From one side, collecting the data, from the other side, let's say, also get the data to, let's say, to the devices that you are going to use. On the very right-hand side of the, let's say, of the presentation, you can see something what we call digital powertrain portal. We know that, let's say, in the future, and even today we are doing this, we wanted to utilize the data. We wanted to analyze the data. We wanted to, let's say, compare like to asset. We wanted to implement some of the machine learning models. We wanted to implement also something like artificial intelligence in the future. This is why also this element needs to be taken into the consideration when you, as an owner, you as a, let's say, product manager, you are, let's say, VP level who decide to build such kind of platform, you have to take this into consideration. All right, as you can see right now on these block diagrams, you have to take into the consideration several different elements, and certification is extremely important part of this kind of, let's say, this kind of system. This is why right now, Cheryl, one more time, thank you very much for starting the meeting. Let's say, let's go ahead and let's say, and talk about how important is certification in all of this process?
Thank you, Artur. My name is Cheryl Beeler, and I am the certification engineer at the mechanical side of the motors mechanical team. And I come from an instrumentation background, so I've had several years of experience both doing product safety as well as certifying instruments for hazardous locations. So we'll get to that, but I will be talking to you about certification as a key element of interoperability. It's important that the certifications be considered at every stage of the product design and development. First, there's going to be some communication requirements. There's what this is showing here is we happen to choose Bluetooth. So we had to register with FCC for the United States. We need to do registration through the ICEES for Canada. And the European Union luckily allows us to do a self-declaration against the Radio Equipment Directive. Those are the base requirements we used for our initial release of the product. I'm also showing on here an example for a country-specific requirement for communication, and that is Mexico. We also needed to register through NYCE for the Mexican marketplace. So it's not just communication, not just the registrations. What we looked at for standards is the Bluetooth standard, which is governed by IEEE 802.15.1. That was our main focus when we were looking at the communications protocol. If you look at the slide here, you see that under the performance, there is no single sensor performance standard. The requirements are going to be based on the application and the type of sensor being developed. So most of the time, manufacturers will define the performance requirements during the initial or early stages of the product development. So we won't be citing a standard specifically. They may bring some in at during the product design, but there isn't something to pin to it immediately. However, it's very important that the products be designed and assessed to not cause harm to humans, domestic livestock, or the environment. So those come into product safety standards. I've listed 3 down here in our standards that we considered. The top one from the International Electrotechnical Commission is IEC 61010-1, And this is a general safety standard that governs the requirements for test and measurement equipment, which most sensors are. The other two standards listed here, IEC 60079-0 and 60079-11, are specific standards for equipment going into potentially hazardous locations, or what we call classified locations in the United States, where they may be used around combustible atmospheres. So these standards needed to be considered early on in the process as well. So many sensors, ours is included, but many sensors are designed to be intrinsically safe. And what that means is that even under specified fault or failure modes, there's not sufficient electrical energy that can be released to cause an ignition. So what you see on the markings is a brief marking here on the lower left-hand side of the folder for EXIA. And this indicates that the sensor is intrinsically safe and may be used where the combustible media is gas, a vapor, or a dust. So of course, with the certifications comes along some markings. I like to call them hieroglyphics. So down here in the lower right-hand corner on the very bottom row, you will see the trimmed down, very truncated markings that indicate that the sensor is suitable for use in potentially explosive or hazardous locations. And these markings include the markings for the ATEX directive for the European Union. They include the markings under the IEEE scheme, which kind of is an international scheme, helps you get into other countries if we needed to. It also includes the markings for the US and Canada based on our national electrical codes. And so you see some very truncated markings. Now these are truncated, so you can imagine the size of sensors. It's very likely that there is limited space on the nameplates, because these markings are required to be on the nameplates. There are allowances to reduce the markings so that the end user has to go see the certificate or the instructions. So don't be afraid to go after hazardous locations. Even though there's a lot of markings, you might be able to get those to back off. So with that, I will hand this off to Van Kruger.
Thanks, Cheryl. Yes, hi, my name is Van Kruger. I'm the VP of US Operations at Cassia Networks. Just wanted to start by thanking the IEEE and their sponsors, along with my colleagues at ABB, that I've had the opportunity to support on a number of gateway sensor products the last couple of years, and present my thoughts to you today. Just real briefly, Cassia Networks, we make Bluetooth gateways, as well as an IoT access controller product. Think of Cassia as kind of the plumbers. We help connect your sensors to your applications, basically, in terms of range and number of devices that can be connected. And so my presentation today will be, coming from that mindset. And so, hopefully you find this, beneficial today. I'd like to start by actually talking about, or maybe defining interoperability from sensor to gateway from a business perspective. So first off, it must be cost effective, seamless, timely, and ensure secure connectivity, for uploading data to a customer facing application. So, what do I mean by that? So in terms of cost effective, in order to achieve mass customer adoption, the ROI must justify the R&D development and ongoing maintenance expenses when considering, putting a solution in place. As far as seamless connectivity is concerned, this is, another area of concern for a lot of folks putting together a solution. The sensor to gateway communication must be consistent and reliable. And then thirdly, from a timely perspective, the sensor data must be available, at regular intervals or near real time in order to provide, actionable and meaningful data to an operator or technician. And then, lastly, I think it's really important that Obviously, connectivity be secure, so, robust enough to avoid growing number of cybersecurity attacks, that we've been hearing about, over the last, several years, all while continuing to maintain company firewall policies and securing data. And let me just talk a little bit more about this end-to-end security, even though today's presentation is primarily, about, gateway to sensor, interoperability. I think it's really important to look at the total solution as well. And so if you look on the display there, looking at, BLA sensor to gateway, there's things like, AES 128-bit encryption. There's different types of pairing mechanisms in terms of OOB secure pairing, as well as numeric comparison, that helps provide protection, to the total solution. But, again, that's just one portion of, the consideration. So if you look to the right, on your display, and you think about, the solution, the total solution that we have in place with ABB, there's the gateway to, cloud communication, even local server communication that's important. So as you can see by the display, I won't spend a lot of time on this, but it's important to note that, there's really encryption throughout. We've got transport layer security, from gateway to cloud, and then cloud to ultimate, IoT application. So, wanted just to set the framework that that's not just, we're not just worried and concerned about, sensor to gateway communication, but we have to consider everything in totality. So in terms of some of the additional interoperability challenges facing IoT enterprises, let me just talk about, three that kind of came to mind as I was putting together, my thoughts. And, this idea of condition monitoring or predictive maintenance isn't necessarily a new concept, but a lot of the legacy solutions that are out there are traditionally, wired solutions and using, pretty much legacy protocols for communication. I think, one of the challenges is, bringing this to the the current smart factory standards by, looking at wireless solutions, which in theory help to lower costs, for deployment, as well as make it, deployments more flexible. And so, one of the challenges in that is, okay, so what wireless protocol do I use? There's a gazillion out there, from, Zigbee to Wi-Fi to LTE, a number of the legacy industrial protocols, sub-1G, protocols. And so, what do I, what should I consider and what should I use? And so part of today, I'll talk about one specific, but, obviously there's not necessarily a right or wrong answer. A lot of it just depends on the specific, business application. And then ultimately, how do I ensure some level of network, reliability, security, and scalability as I look at defining and ultimately building, this solution. So what I'd like to do today is really make this case for Bluetooth for industrial IoT. And on my screen, it says Bluetooth, but I can assure you I'm actually talking about Bluetooth. And, typically, when you think of Bluetooth isn't something that you necessarily associate with IoT. But today, one of my goals is to maybe get you to thinking about it a little bit different as you're looking at building out, a solution. So to start with, let's start with some of the advantages. Bluetooth, is, fairly low cost. Probably one of the biggest advantages is its low power consumption. So if you're wanting to use a battery powered sensor, obviously you're looking for, extended, battery life. So, this BLE or low power is, very key and very important. Bluetooth is also an open protocol, so it's fairly easy to develop solutions on. And ultimately, if you're not necessarily looking at building your own devices, but want to leverage, other, devices that are already on the market in terms of putting together an end-to-end solution, Bluetooth is pretty much universally available. I think the Bluetooth SIG is currently projecting that by 2024, there'll be 6.2 billion Bluetooth devices that will be shipped annually. So, you know, if you don't necessarily want to build it, there's probably maybe somebody else out there that's, you know, already, you know, thought of it, and there may be a solution that already exists, you know, for you to integrate and incorporate. So, you know, so those are the good things about Bluetooth, you know. However, you know, Bluetooth was originally designed just to replace the cable. So if you think of your mouse, you know, and having the ability to be untethered by a cable, you know, I think that's where Bluetooth originally, you know, had its inception. And so, you know, it has some, in terms of what it was originally designed for, it has some, you know, fairly significant limitations as you think about, you know, trying to network a solution. Typically, you know, fairly short range, 10 to 20 meters, limited device pairings, you know, like, for example, your phone to one device at a time. No ability to, you know, remotely control devices unless you're on the same, you know, subnet, you know, making it very difficult, you know, to manage, you know, devices or, manage devices on the network. And so that's where, you know, really Cassia and other Bluetooth gateway, you know, vendors come into play. And so again, I'm not necessarily pitching Cassia today, but I think what I'd like to do is suggest some things that you should probably be looking for as you look to evaluate, you know, a gateway partner. So, you know, on the screen, you can see a number of indoor, outdoor, industrial gateways. As I mentioned, some of the problems earlier, you know, in terms of range, 10 to 20 meters. Well, with a long range Bluetooth gateway, you can actually get up to 400 meters with Bluetooth 4 and up to 1 kilometer with Bluetooth 5. You know, a lot of people don't realize that, you know, you don't need necessarily sub 1G protocol in order to, you know, get to for some fairly, you know, significant range. And I think that's important to keep in mind because, you know, one of the things Bluetooth, and again, not to necessarily disparage any other protocols like NB-IoT or LoRa, is if you've got a fairly significant payload requirement, you know, you may start to run up into challenges in terms of bandwidth for some of those sub 1G technologies, which typically work really well for long range. So, you know, in this case, you know, Bluetooth can actually, you know, maybe doesn't necessarily completely replace, you know, like for example, an NB-IoT, but it can actually extend what would typically be kind of a local network to a fairly, you know, much more extended than what, you know, one might actually think. And then the other thing to consider is that instead of this one-to-one pairing, now it's possible to have actually simultaneous, a reasonably simultaneous two-way communication up to 40 devices. We have one partner who's actually just has sensors that are broadcasting that don't require two-way communication. And I think they were testing, you know, well over 500 beacons with a single gateway in their lab. And the only reason they didn't use more is because they ran out of beacons. So again, this idea of being able to, instead of having one-to-one communication with a smart app, you're able to aggregate, you know, sensor data through, you know, multiple sensors through, you know, a single gateway. The other thing that's important as you look at, you know, your Bluetooth gateway options is, you know, the type of backhaul options that are available. And so, you know, a good solution should include Ethernet, you know, Wi-Fi, you know, potentially some type of USB or, you know, cellular LTE modem backhaul as an option. The other thing that's really important is this concept of edge computing. Or actually, you know, even before I get there, let me go back to the backhaul. You know, one of the things I was just thinking that, you know, we see with a number of our partners is, you know, this challenge, and this is really a challenge, you know, getting these solutions deployed is, you know, you've got these fairly strict corporate policies. And what we're finding is that, it was a surprise to me, is that more and more folks are actually starting with cellular backhaul because they can actually get a solution deployed without having to interfere or negotiate with corporate firewall policies. So, you know, folks will start off with cellular and then look to cost reduce, you know, to say, for example, Ethernet or Wi-Fi, you know, once all of the security concerns have been, you know, addressed. And so again, having this ability to have, you know, flexible backhaul options is really important. Now back to edge computing. I think, again, this is another really important area particularly if you're going to be using cellular for backhaul, depending on the amount of sensors, sensor data that you're trying to collect. I mean, again, if you're just sending out heartbeat data, probably not that big of a deal. But if you're sending out, fairly frequent, bursts of data with, say, lots of diagnostic information, et cetera, then, cost starts to become a consideration. And so looking for ways to kind of better manage those devices at the edge, as well as potentially controlling cost in terms of what you're backhauling. A number of our partners are actually, running their third-party applications at the edge, on the gateway. So, looking for, whether it's a Cassia solution or one of the other, manufacturers out there, looking for, edge computing support, I think is really important to consider. And then as you go over to the right on the screen here, it shows an IoT access controller. And most of all of you are probably familiar with Wi-Fi, whether it's Aruba or Cisco, et cetera, and this concept of an IoT access controller for managing a Wi-Fi network. Well, the same requirements really hold true, for Bluetooth as well. So this ability to be able to have a centralized management solution, that helps to provide end-to-end security, as well as makes it easy, to integrate. And when I say easy to integrate, providing things like RESTful APIs where, makes it easy for you to, basically talk to your application, or I should say extend the communication from your application through the gateway, to the end sensor. Some other, features as well, that can be also significant for an IoT access controller is this support for Bluetooth roaming, positioning, et cetera. But, ultimately, this comes down to when you're thinking about a fairly significant deployment, you don't want to have to manage one gateway at a time. So having this centralized management tool is really key. So as we think about, Industry 4.0, when I first started working with ABB, probably on the first project, probably a little over 3 years ago, we started off, just with looking at, vibration sensing, in a gateway, and looking at basically replacing the single smartphone where a technician had to walk around to one sensor at a time and collect data, to being able to collect data from multiple sensors through a single gateway up to the cloud. I think the key, here is that once you have a gateway, in a smart factory, now you can continue to add value over time. And so, as with the relationship with ABB, we've continued to, add different sensors, once that gateway's in the factory. And then most recently with, Artur's team, we've actually extended this one step further, where not only collecting sensor data with the gateway, but we're also enabling with OPC UA server software, enabling communication with a PLC, OPC UA client device. And so really, we see this as the vision, for the smart factory, of the future. So some of the challenges facing end users, let me just cover a few of those. And some of these are pretty obvious, in terms of total cost of ownership, obviously that's a big challenge. Part of when you're selling a solution into the channel, it's, if it's not broken, why fix it? Well, I think, one of the areas which is, a really strong selling point is this idea of cost reduction. So this idea of having a gateway that can provide, flexibility and the ability to connect to multiple sensors at distance basically means that you have, fewer gateways. And the idea of an access controller, this ease of management, also plays into, literally you can have a, global monitoring going on with one person in front of a computer with internet access. And so this idea of being extremely efficient from a resource perspective, again, I think this really plays into helping to solve this challenge of, total cost of ownership. We talked about cybersecurity and data loss. I won't really go into that much here, but again, we talked about that earlier. Solution scalability, just as an example, with this access controller that we provide at Cassia, you can support up to 5,000 gateways with a single access controller. ultimately, we have a roadmap where this will be pretty much, unlimited, and so again, as you're building and considering a solution provider, it's very important to think about, how you're going to manage those devices and, gateways in the field. Device integration, touched on that, earlier. RESTful APIs, really, really important. Look at the solution provider. How difficult is it to, integrate your device, your GAP profile or Bluetooth profile of your device with, the gateway provider's gateway. So I think it's really good to focus in on their RESTful APIs to start. Again, we talked about ongoing cost of data, and it's really, again, it's not trivial. And so again, having that flexible backhaul option where, again, you may get that business opportunity launched with cellular, but having the ability to cost reduce that with either, the use of, edge software at the edge, or by going into a more, intranet, or I should say more like, Ethernet type of network structure, to reduce cost. That's something that needs to be, part of the potential solution consideration. And then lastly here, just a couple more, in terms of product data sheet accuracy is a challenge, taking advantage of and leveraging, certification organizations, I think is really important. And, sensor performance parameters, again, being sensitive and compliant, with, to the standards that are out there. Again, I think, taking advantage of the resources that are available to you, I think is very important. And with that, I'm sure you have lots of questions and look forward to answering any of those at the end of today's presentation. But I'd like to turn things back over to Artur to kind of summarize today's discussion.
Van, thank you very much. Cheryl, thank you very much for a very good, let's say, overview. And as a summary, let's say, from this side to such kind of extremely short, let's say, webinar, I can see there is a lot of questions on the question answer sessions. Of course, let's say, please add more. Let's say we will do our best to answer. But let's say, as a summary from today's webinar, let's say there is the three main very important points to, let's say, to consider. If you are the owner, if you are the platform owner, if you are considering, let's say, going towards such kind of directions, or if you wanted to partnership with someone, first of all, required certification. You know your market, let's say we know our market. We have to take into the consideration what kind of certification we're supposed to use. If you are talking about this kind of ATEX, ICEX certification, it's have to be taken into the consideration. Also, let's say because of the certification of the radio frequency, this is such kind of additional point that you have to take into the consideration. Also knowing your, let's say, your customers, your OEM customers, your channel partners, your distributors, you have to really start to talk with the, let's say, with your partners, let's say, before you will go towards such kind of directions, because it could be, let's say, pretty big surprise for you if some of the OEMs said, let's say, that they end customers, they are located in South America, or they end customers, they are located in China or India or South Africa. And if you do not take into the consideration this kind of certification, this can be very, let's say, very not so easy, let's say, surprise on the, let's say, on some point over the, let's say, of the time. Second, let's say, also when we are talking about this kind of end customers, let's say, applications, this is also extremely important because not only, let's say, the certification, also determine, let's say, where you are going to, let's say, physically use this kind of, let's say, this kind of equipment. Well, let's say Cheryl mentioned today about this kind of radio frequency certification. Some of the customers, for example, let's say oil and gas customers or grain customers, where the, let's say, the sensors can be and the gateway can be located on this kind of explosive, let's say, atmosphere for some period of time. Let's say this kind of physical location of the sensors also have to be taken into the consideration. Also, physical location of the gateway have to be. Kasia, let's say, Van, let's say, present to you a couple of different options of the gateways today, and one of them is, let's say, from the ATEX application. Means, let's say, you have to take into the consideration how far from, let's say, from the sensor at point, let's say, you are going to implement this kind of, let's say, this kind of devices, and what kind of regulation will have. It means first, let's say, required certification, physical application, physical location of the, let's say, of the equipment, extremely important, and plus, let's say, physical, let's say, parameters what you wanted to sense. From our perspective, because we are on this kind of mechanical, let's say, heavy equipment, let's say we are focusing on the, let's say, on the vibration temperature. But one of the one slide you have seen, let's say, we can sense a lot of different parameters. This is why physical location of the sensor, physical location of the gateway, this is something, let's say, you should, as an owner, as the product owner, as a VP, as a platform, let's say, the architect, you should take into the consideration. Also, let's say, selecting the right wireless communication protocols. Van just give you such kind of overview of the several different protocols, what we took into the consideration on the decision process. And you have to most probably go through exactly the same, let's say, the same process. We have a lot of, let's say, concern about the cybersecurity. And for example, if you decided to have such kind of, long-range communication protocols, you are exposing yourself into, let's say, much more broader, scope of the possible attack to, let's say, to your system. This is why if you decided to go towards such kind of directions, absolutely you have to take this into consideration. This is how, let's say, proper, let's say, wireless communication protocols will determine almost all the other elements of the system. Of course, we decided, and this is last bullet point and such kind of summary of our activities today, we present to you, let's say, our solution based of our investigation, based of the discussion with our partners, based of the discussion with the, let's say, our ABB Ability internal, let's say, system architect. We decided that Bluetooth, this is very good combination of the range, cybersecurity, flexibility, and scalability. And of course, you as an owner in the future, you have to select if the Bluetooth is the best choice, best options, or maybe if you select, let's say, any other communication protocols, you have to, let's say, build a system around it. That's it from, let's say, from us from today. Thank you very much for the invitation. Thank you very much for the discussion. And then I'm just giving it to the Brent, and we are waiting for some of the questions. Thank you.
Okay, thank you all. Very insightful, very interesting use case that applies to many that are trying to introduce industrial IoT. I want to say thank you to ABB and CASIA Networks. Again, very compelling use case. I also want to remind our participants to post any questions you have to the Q&A session, which we're about to get to in just a minute. So what this is, we have a call to action here. The IEEE Sensors Council, working in collaboration with the Standards Association, have a call to action to advance existing and new sensor standards. And what we've learned today is that many industries depend on sensors, and sensors are affecting all of our daily lives, from smart cities to smart mobility, to traditional mobility, industrial automation, to medical devices, to smartwatches, and consumer electronics. New market technologies facilitate the rapid growth of IoT-enabled smart sensors. But we've got a lot of changes in the future. We've got 5G and 6G internet. You have to be concerned about microprocessors, communication protocols, and better performance. Big data, cloud, innovative applications, better performance is always going to be a driver in this industry. But this all comes at a cost for interoperability. So what are the main challenges? We talked about some of them today. Interoperability. We've seen it's possible in closed loop systems by integrating a sensor in a gateway with the manufacturers. We've talked about new technologies, which will compound interoperability problems unless the industry takes action with modifying existing and creating new standards. We have concerns about product misrepresentations that may come from internal testing. Many product data sheets are not as accurate or factual as systems integrators need them to be. And the IEEE has created a sensors registry, which lists sensors devices that have been verified by IEEE. That's a very important point about this initiative that we're all on here. And cybersecurity. We have a lot of questions about cybersecurity today, often implemented by individual components, but not by the entire ecosystem. There's no recommended cybersecurity protocols to help with IoT implementations. So although we've got quite a few questions about cybersecurity today, I want to highlight the fact that our webinar number 3 in this webinar series will be held in November, and it will be dedicated to discussing cybersecurity. So stay tuned. I encourage all of you to join webinar number 3, again, in our series. Additional challenges include non-compliance to standards. Some industries, like the consumer electronics industry, use Google APIs, and this serves as a de facto standard to access sensors. This complicates the sensor's lack of compliance, but it mitigates the interoperability problems. And again, we've talked about new technologies, but 5G is oncoming, 6G will follow, cloud, big data, it continues to grow and change, and communication protocols will compound compliance and interoperability problems, which are opportunities. This results in additional testing costs for the integrators and the implementers. We're trying to save this, what can turn into extensive cost for integrators. There are existing IEEE standards. We have a portfolio of sensor standards, including IEEE 1451. And I did want to mention, well, first, it's a set of network independent communication interfaces for connecting transducers to servers and specifications of electronic data sheets, transducer electronic data sheets. Also want to mention that within that standard is a calibration protocol. So there were some questions about calibration. If you take a look at that standard, you'll find calibration, information, instructions, and protocol. IEEE 2700 is a minimum set of performance parameters defined with required units, conditions, and distribution for each MEMS sensor. IEEE 2888 is a framework for MEMS sensor performance, specification terminology, units, conditions, and limits. But we need to develop standards that have industry support. It is crucial to have industry involved in the advancement and creation of IEEE sensor standards to address fundamental framework issues from a system-level integration and to work with current and emerging technologies that will serve as a base for conformity assessment programs and ultimately IEEE certified products and services. So how can we address this challenge? We are planning a roundtable meeting to discuss the industry needs for IoT-enabled sensor devices. And this will cover areas of interest that we've talked about today and your questions are related to: interoperability, cybersecurity, and restoring trust in product specifications and data sheets. So why? The market is experiencing rapid and unprecedented growth in sensor technology. And it's important for the industry to assess issues and recommend a plan to mitigate them. The participation in this roundtable meeting, this is good, again, industry. We need industry executives, CEOs, CTOs, product architects, and managers. We expect participants from manufacturers, solution providers, SDOs, academia, and test laboratories. But industry is crucial in driving the advancement of IEEE sensor standards. This roundtable discussion will, this roundtable meeting will occur in the IEEE New York City office. It will be in Q1 of 2022. And we have an email listed there for those that are interested in this roundtable meeting. So I'd like to get on to questions and answers. Again, thank you to everyone that's participating. Let's see, let me look at the questions here. I have a question here for Arthur. Which cloud do you use when selecting, what are your selection criteria?
Okay, this is fantastic question, and I remember from this kind of diagrams what I presented almost on the very beginning. we selected Microsoft Azure as a, let's say, as a very good partner. And honestly speaking, we have most probably 2 or 3 different choices. And to be very honest, also, let's say, we as ABB, we were trying to, let's say, to do this kind of cloud solution by ourselves for the, let's say, for the couple of years. And we decided that, being the partner with the Microsoft, especially on the Azure side, is much more, let's say, better because, let's say, we can fully focus on our main domain expertise, what is really related with the sensor technology, data analytics, machine learning model, instead of the developing something what is already very well developed. And our selecting criteria was, let's say, first of all, let's say, the cost of the, let's say, of the cloud. Second was, let's say, was the, let's say, all kind of, let's say, Azure functions that we can use, let's say, for the today's, let's say, application and also for the future functions. And of course, let's say, last but not least was, let's say, extremely important, the cybersecurity. It means what kind of cybersecurity protocol, let's say, Microsoft proposed to the customers to make sure that, let's say, that we are on the, let's say, always on the safe side.
Okay, thank you. We have another question here. The semiconductor industry introducing analytics on chipsets for IoT systems. When do you see the IoT sensor will have AI and analytics capability? Who wants to take that one?
I will also start to answer to this one. We already see that the capability of our sensors, honestly speaking, because we are very strong on this kind of mechanical part of the business. When we have, let's say, gearboxes, we have bearings, and just, let's say, I will just give the example of the bearing fault frequencies. We are able to do it even today. Let's say, honestly speaking, some of our future, let's say, firmware development will include such kind of, we call it edge computing. But of course, let's say, this kind of edge computing have some limitations. It's only, let's say, limitation they are related with amount of the data who are able, let's say, to capture, and also, let's say, capacity and, let's say, and energy consumption required for such kind of, let's say, such kind of calculations. This is why, let's say, one more time, you as an owner, you have to take into the consideration, if you are really considering this kind of edge computing capability on the sensor itself, then you have to really, let's say, think about, let's say, additional power source. Or if you wanted to make such kind of preliminary edge computing on the sensors and send some aggregate information to the cloud where we can perform, let's say, much more deeper, let's say, deeper analytics. This is why, let's say, it is always such kind of trade-off, let's say, approach. Let's say, how you wanted to serve your customers, and honestly speaking, let's say, what your customers they are looking for. Because we have a couple of customers who already have this kind of analytics team, let's say, very well developed on their own organization, and they are much more interested, let's say, to really get their own data, FFT, let's say, data, and let's say, perform this kind of analytics, let's say, by themselves. This is why everything is dependent on the voice of the customers and markets that you are going to serve. Thank you.
Okay, good deal. Thank you for answering that. A question from Stefan. Thank you for the presentation. My question is about sensors. Do sensors need calibration? How do you optimize the calibration of deployed sensors in order not to impact the client?
This is a fantastic question. One more time, let's say, we have to take a look on this kind of, let's say, functions, what the sensor is supposed to deliver, or let's say, benefit the sensor is supposed to deliver to the end customers. In our solution, the presented sensors today is much more, let's say, condition monitoring process. It means we are looking for such kind of, let's say, IoT solutions provide you such kind of, let's say, change over the time on some, let's say, crucial parameters of the equipment. This is the main purpose of the sensors. This is why from this perspective, let's say, we fully rely on such kind of, let's say, vendor calibration of the accelerometers, vendor calibration of the temperature sensors. But of course, let's say, we have a capability, and today our customers do not require this kind of, let's say, this kind of calibration today. But we have a couple of customers, especially for the air handling application. Those guys, they are really working on such kind of high-speed application that sensors have to be very accurate. And for those customers, most probably for the future, we will provide them such kind of options of the calibrating the sensors over the time, or calibrating the sensors almost out of the box. This is why, one more time, let's say, what kind of market we wanted to serve. Let's say, what kind of certification and customers required. One more time, let's say, we are talking IEEE, because let's say we have some standard also for the calibration. This is why everything, let's say, related with the, let's say, what kind of customers and what kind of market we are going to serve.
Okay, thank you very much. Vaughn, I have a question here. Bluetooth is a network solution, but not an application standard. Do you support Zigbee and Matter over Bluetooth for interoperable solution at application level?
The short answer is we use a Nordic chipset that does, primarily, it's designed the way we've implemented it right now. It works with Bluetooth, but it can support Zigbee as well. It's really just it's just software, additional software support that's required, but all of the hardware is in place to provide the support that they're looking for.
Okay. All right. Thank you. Let's see, another question here from Robert. Are the communication security methods only transport, or are the methods for encrypting the data end-to-end, such as the sensor to the cloud server? Do I need to read that again?
Yeah, if you could, that would be great.
Are the communication security methods only transport, i.e. Bluetooth, AES, TLS, or are methods for encrypting the data end-to-end, i.e. sensor to cloud server?
Yeah, I think, again, it really comes down to the business requirements of what's needed. I mean, encryption, I would envision encryption from end to end, and there's different mechanisms that can be used to shore up the security, in the path. As an example, I didn't mention today, but our latest gateway supports or has an embedded crypto chip. So if you're wanting to have total trust, that's something else that you can look at, specifically at the point of the gateway. So every point in the process where there's a touch point, there's an opportunity for encryption, basically.
Okay.
I will just add something what Van just said. It means this is one more time, let's say the literally decision on our customer side. It means, we have the options to, to encrypt the data from the sensors to the gateway, and we have such kind of, such kind of protocol implemented. Honestly speaking, customers can set up, personal identification number, what will give, this kind of 128-bit decryption and encryptions between the sensors on the gateway. And of course, from the gateway side, between the gateway and the cloud and to the browser, of course, we have the TLS, version 1.2 also embedded. This is why, honestly speaking, you have to take a look for the whole, complete, honestly speaking, the information, transfer, functions, and implement some of the, security aspect.
Yep.
Okay. Okay, thank you. We're just about out of time. I want to thank our presenters today. This is a wonderful business case and very inspiring, insightful. We need to take note here. We have a quick 5-minute survey at the end of the webinar. Please fill out the survey. Again, it's only a 5-minute survey. Our next webinar, it's focused on cybersecurity, so sensor cybersecurity. And we will be announcing that speaker and the date in November soon. But for speaking, if you're interested in speaking or sponsorship opportunities, we have a contact email listed there, sensorsregistry@IEEE.org. And again, I want to thank everybody for joining us. I want to thank our speakers. I want to thank IEEE Standards Association. So coming from IEEE Sensors Council, I want to thank you all.